We have the other one, question number 30, and we are given a set X, A, B, C, D, and Y is given to be 1, 2, 3, 4, 5. And then f from X to Y is a function such that 4 is always in the range of f, and f is not an injection. So let n be the number of such functions. That means we need to count the number of functions for which this is satisfied, that 4 is in the range and f is not an injection. And n be the number of solutions of this such that x, y, z are in AP. So we need the value of n plus n. All right, let's go ahead. So I have here, suppose this is my set X, and this right here is my Y. So I have here A, I have B, C, and then D. And this side we have here 1, 2, 3, 4, 5. So now what happens? So we want the function 4 must be in the range of f and f is not an injection. So we can consider the case. Case 1 is that when all the elements are mapped to 4. All elements are mapped to 4. So in this case, what will happen? So it will become a constant function. That means A, B, C, D. So all of them are going to be mapped to 1. So A is also mapped to 1, B is mapped to 1, C is mapped to 1, D is also mapped to 1. So in this case, we get only one function. So here we have only one function. Now, second element is that any two elements are mapped to 1. Okay. So any two elements are mapped to 1. So any two elements are mapped to 1. Now let's see. So in this case, out of these 4, we will select any two elements and we will map to 1. So it's like this, basically. This is overlapping here. Let's see, how can I make it correct? Okay. So we have it this way. Now we are saying that any two elements are mapped to 1. So out of these 4, I have selected any two elements. Let us say I've selected B and C, and I'm mapping it to 4. So now A and D have 1, 2, 3, and 4, and A has 4 choices. And similarly, D also has 4 choices. They can be mapped to 1, 2, 3, and 5. So each A and D have 4 choices, which gives me 6 into 4 into 4, which is 96. So here 2 elements are mapped to 1. Now, the third case we will take the 3 elements are mapped to 1. So 3 elements are mapped to 1. Not 1, 4. So 3 elements are mapped to 4. So for 3 elements are mapped to 4, what we will do? I'll be again creating the same scenario, and my function would look somewhat like this. Now, out of these 4, we will select any 3 elements and then map it to 4. So now D has, out of these 4, we'll select any 3 element and map it to 4 in one way. And then D has again 1, 2, 3, 5, 4 choices, which means from here I get 16 functions. Now, let's go ahead. Now here what we will do, first we will select any one. I'm saying only 2, any 3. Now take the fourth case, because we have not counted the entire function. There can be still one more function like this, that exactly one element is mapped to 1. Exactly one element is mapped to 4. Sorry, one element is mapped to 4. So exactly one element is mapped to 4. So in this case, what we will do, first we will select, let's just give a picture here, because this gives a clear idea. So I have this thing. Now what we will do here is, out of these 4, first I'll select any one element. Suppose, let's say I selected C, and C I'm mapping to 4. Now what happens is, see, I want my function should not be 1, 1. That means what I'll do, I'll select another 2 elements now. From out of these 3, I'll select another 2 elements. So out of these 3, select any 2 element. And now these 2 elements, I can map to 1, I can map to 2, I can map to 3, I can map to 5. That means they have 4 choices. So these 2 elements have 4 choices. And then once this thing is done, so now another one more element is pending. So that has only one choice less, which is 3. So this task is done now. Or there could be one more thing here. I can select again one element here, and then instead of selecting this two element, I can select all three of them remaining, and then they again have four choices. So this gives me further 4c1 into 3c2, which is 4, and 3c2 is 3, into again 4, again 3, and then plus 4 into 4. So this will give me 4 into 4, 16, into 9 is 144 plus 16. This gives me 160. So we have here 160 functions. And this way we have counted all of them, all of the functions. So this 160 plus 16 plus 96 plus 1. So total number of functions, that means m is going to be total 160 plus 96 plus 16, 160, 96, 16, and then 1. So now this total would give me, on adding all of these, we get basically 160 plus 96 and then 16 and 1. So this is 160 and then 96 plus 1 is 97. And then we have here 16. So this is 3 here, and 9 plus 6, 15, 116, 7, and then 2. So this gives me 273 functions total. So we get here 273 functions. And now we need to go for finding n. So n is basically asking us to find the number of solutions for this thing x plus y plus z, so that x, y, z are in AP. So we have x plus y plus z is equal to 24, and they are in AP. So if they are in AP, that means x plus z is nothing but my 2y. So I can plug in here. So this is going to give me 3y is equal to 24, which means y is nothing but 8. So the moment I take y is equal to 8, I can plug in here. So which gives me x plus z is equal to 24 minus 8, which is 16. Now I need to find the number of solutions here. Now only two variables are left, x and z, and they both belong to natural number. That means I need to find the positive integral solutions. So positive integral solutions of x plus z is equal to 16, which is nothing but 15c1, which is nothing but 15. Because number of positive integral solutions for x1 plus x2 and so on is nothing but n minus 1c r minus 1. So we can use this. So this gives me 15. So therefore, n is equal to 15, which means m plus n will give me 273 plus 15, which is 538, 718. So this gives me 288. So the final answer would be here 288. Now moving to the next. Okay, so question number 31. This looks like a monster matrix, and then f of x is given to the determinant of this matrix, and then we need to find the value of this product, which is nothing but r is equal to 1 to 2024, and then we have to find f of r into r minus 2019. This over 2018 factorial into 2019 factorial. We need to find out this thing. So, of course, no one would go and find a determinant for this matrix. Eventually, I won't go for sure. So first, let's simplify what is this turns out to be. So let's open the product and see if we can get something. So this is going to be f of 1 into 1 minus 2019, which is minus 2018, into f of, next is going to be this 2018, and all these things will be they're repeated 2024 times. So we can just write down at the bottom 2018 factorial into 2019 factorial to the whole power 2024, because they will be repeated 2024 times. So now this is going to be next here 2 into minus 2017, and then so on. So a stage will come here when I'll be writing here 2019 into 0, and then next will be 2020 into 1. And this is the most important guy here in this entire expression. This is f of 0. So let us see what is f of 0, by the way. So if I see here f of 0, then f of 0 is going to give me a determinant of a. So if I have this expression, a determinant of a, and I need f of 0, so then that means at the place of x, I can write down here. At the place of x, I can write down entire 0 there. So this will give me 0 here. This will give me 2018 factorial. And this is going to give me minus 2019 factorial. And this guy will be again minus 2018 factorial. This is 0. This is 2020 factorial. And then we have here 2019 factorial. And this is minus 2020 factorial. And then again, this is 0. So now this turns out to be 3 cross 3 skew symmetric matrix. So this is a 3 cross 3 skew symmetric matrix. And its determinant is going to be 0 here. So this f of 0 turns out to be simply 0, the determinant, because f of x is nothing but determinant of a. So which is 0. That means this entire expression turns out to be simply 0. So the answer would be 0. Get this, we have another guy in the town. Question number 32. So f of x is a monic polynomial of degree 4. So f of x is a monic polynomial of degree 4, which means it will be like this: x power 4 plus ax cubed plus bx square plus cx plus d. It is going to be of this type, and then it satisfies this expression because we have 1, 2, 3, and 4 integrations. And f of x, where f1, f2, f3 are non-constant, continuous, and differentiable functions. All right, then the value of 10 times the area bounded by f of x and the line y equal to x minus 1 is what? Okay, so now if we observe this polynomial carefully, so we have here 1 to x for, oh no, there is no point. Let's write it. f1, f2 t dt into again 1 to x, f3t into f4t dt minus integral 1 to x f1t into f3t dt, and then again integration 1 to x. This is going to be f4 of t into f2 of t dt is equal to my f of x. So if you watch carefully, then I can find out here f of 1. So f of 1 turns out to be, this is 1 to 1, 1 to 1, 1 to 1, 1 to 1. So all of them become 0. So my f of 1 becomes 0. That's the first achievement. Now I'll think of differentiating, because this way anyway is polynomial degree 4. So I'll think of differentiating him. So if I differentiate, this will turn as my u, and this is v. So let's perform the Newton-Lennez rule. So keeping this one here itself, f1 into f2, I'll not be writing t, it is to be understood here. So f1 of t into f2 of t, this will be as it is, and then integration of this will turn out to be f3 of x into f4 of x by the Newton-Lennez rule, and the second part becomes 0. So plus, again now this will be treated as u, so f3 of t into f4 of t will be as it is. Derivative of the first guy is going to be f1 into f2, this thing, and then minus, if I differentiate this thing, so this will remain as u. So again I'll be having 1 to x f1 of t into f3 of t dt, and then the derivative of this thing turns out to be f4 of x into f2 of x, this, and then again this will be minus here. So 1 to x f4 of t and f2 of t will rest here nicely, and meanwhile this guy will be getting differentiated. So this will be f1 of x into f3 of x is equal to f dash of x. Now let's see again, can we do something here? So yes, if I plug in again 1, so I'm going to get here 1 to 1. This entire thing becomes 0. 1 to 1 again 0, 1 to 1 again 0, 1 to 1 again 0. So in this case, I get f dash of 1 also to be 0. Now, let's notice something here. So if I differentiate it again, so what will happen? This part will become u and this part will become v. And then I'll be getting here f1, f2, f3, f4 in one of the part. And the second part will have integration followed by this thing. The same story will happen here also. F1, F2, F3, F4, and then F3, F4 will appear under integration. And the same story continues here, but with minus. So that means the first part which is left here, F1, F2, F3, F4, will get cancelled here, basically. And then F1, F2, F3, F4 left here will get cancelled here. Again, I'll be putting a double dash of 1. So again, 1 to 1, 1 to 1, all of them will become 0. So basically, we get to know that f double dash of 1 is also 0, and f triple dash of 1 is also 0. So now we see that f of 1 is 0, f dash of 1 is 0, f double dash of 1 is 0, so f triple dash of 1 is also 0, which means my polynomial is simply x minus 1 to the power 4. Because second, third derivative to 0. So that means f of x is nothing but x minus 1 to the power 4. So now I need to find out the area bounded by the lines, no, not lines, y equal to x minus 1, and then x minus 1 to the power 4. So that means I need to find out this area first. So x minus 1 to the power 4 will be just, the graph will be a bit shifted here like this. This is 1 here. And then I have the line y is equal to x minus 1, I guess. This was correct here. Yeah, y equal to x minus 1. So y equal to x minus 1 would be when x is 0, y is minus 1. That means here. And when y is 0, my x is 1. So this point only itself. So this line will go this way. And then I need to find out this area basically. Because we want the area bounded by the line and the function f of x is what? X minus 1 to the power 4. So this point of intersection, we know it is 1. We need to find out this thing. So to find out this thing, we will have here x minus 1 to the power 4 is equal to x minus 1 later. So now this will be x minus 1 common, and then x minus 1 cube minus 1 is equal to 0. So which means x is equal to 1. This already we have found. And then x minus 1 cube is 1, which means x minus 1 should be again 1. So that means x is equal to 2. So this point is again 2. So now I want the area. So area would be simply what? Integral 1 to 2. The upper curve is x minus 1, and the lower curve is x minus 1 to the power 4 dx. So x minus 1 will be simply x minus 1 square over 2, and limit goes from 1 to 2, minus x minus 1 to the power 5 over 5, limit goes from 1 to 2. So let's plug in here 2. This gives me 1, minus 1 is 0, so bye-bye. And 1 over 5 will be here, and 2 minus 1 is again 1. So half minus 1 by 5. So 5 minus 2 is going to be 3 over 10. So area is going to be 3 over 10. So if I take the 10 times of area, so I get here 3. The answer here is going to be 3. Let's move to the next. Okay. Question number 33. Robin has to travel from city A to city D, changing buses at stops B and C en route. So this is A, and here we have D. And Robin is going to change the bus at B and C. So here he will change the bus, and again here at C he will change the bus. And then he will reach here. So that's how Robin will go. And now let's see. The maximum waiting time at either bus stops can be 8 minutes each, and any time of waiting up to 8 minutes is equally likely at both the places. Okay, so he can afford up to 13 minutes of total waiting time. And if he has to arrive to city D on time, so the probability that Robin would arrive late. So we can assume this thing that at B, suppose let's say he waited for X minutes. So let's say X denotes the waiting time at B. So X is my waiting time at B. And I'll take here at C, let's say Y be the waiting time. Because see, we do not know the waiting time, how much. So it is in seconds, minutes, it is point. That means this is basically a geometry question pure. So X is my waiting time at B and Y is my waiting time at D. So I can consider this way. Let's say this is my X here and this is going to be my Y. Now, if I consider this part, then I know that at either of the bus stops, he can wait only at 8 minutes. That means on B, he can wait only up to 8 minutes. And on C also, at C also, he can wait only up to 8 minutes. So that means I'm going to have a feasible rectangle here because he can wait up to 8 minutes only. And now the next part is what? That means if he want to come to the city D on time, he can afford only 13 minutes of total waiting time. So that means combined waiting time of X plus Y should be less than or equal to 13. If he has to be on time. So if he want to be late, that means our required condition is X plus Y should be more than 13. This implies Robin would be late. So this implies Robin would be late. So X plus Y is equal to 13 will be some line like this. So this is my X plus Y is equal to 30. So now I want to see whether this line will intersect here at what point. So this is my line X is equal to 8. That means, sorry, Y is equal to 8. That means this point is going to be 30 minus 8 is 5. So up to here we get this to be 5. So this is 5 here. And then, so if this is 5 here, so this is going to be 3. And then for this line, this is going to intersect here at x is equal to 8. So my y is 5. That means this is again 5. So this turns out to be 3. Now, x plus y less than or equal to 13 is towards the origin, and x plus y is more than 13 is away from the origin. So I want away from the origin, and this x and y, that means inside the rectangle it should be there. So if I want my probability, so that means I'll be covering this area. So therefore, probability that Robin will be late. So probability that Robin will be late is nothing but the area of this triangle. So area of this triangle over area of this is square. So area of triangle is going to be what? Half into base into height over the area of square will be 8 into 8. This turns out to be 64. So 9, 3 into 3 is 9 over 64 into 2 is 128. So the answer would be 9 over 128. This is the probability that Robin will be late in the city D. Coming to the next question. Now let's look at this. Number 34. So we are given an integral f of x is equal to, so f of x is equal to integral 0 to x f of ln t over t into 1 plus t square dt and plus 1. This the whole multiplied by 1 plus e to the power 2x. And we are given g of x is f dash over f of x. So we need the integral from 0 to ln to e power t into g of dt. All right. So the best thing that would come to our mind is transform this f of x or transfer this 1 plus e power 2x to this side and simply integrate on both sides. Not integrate, I'm sorry, differentiate. So f of ln t over t into 1 plus t square dt and then plus 1. So now I'll be differentiating. So here I have to perform the quotient rule. So this will be 1 plus e to the power 2x, the whole square, and then 1 plus e to the power 2x would be now resting here. Derivative of f will be f dash of x minus f of x will continue to stay here, and then derivative of this is going to be 2 into e power 2x. This thing is equal to. Now on this side, I just have to worry about this x. So f of ln of x. Well, this is not x, this is e to the power x, by the way. So ln of e power x is going to be simply x over, this is going to be t. So which is e power x into 1 plus e to the power 2x. That's t squared, so e power 2x. And then this plus 1 will become 0. So luckily, we have 1 plus e power 2x getting cancelled, one of them. And then now we have here, okay, let's transfer this one to that side. So I'll be having from here, from this equation, I'll be having 1 plus e to the power 2x into f dash of x will be equal to, I'll transfer this one to this side and then add it here. So this adds 1 plus e power 2x, and then plus 2 times e power 2x into f of x, which means I now have f dash of x over f of x is equal to 1 plus 3 into e to the power 2x over 1 plus e to the power 2x. So this is f dash of x over f of x. Now, once we have found one f dash x over f of x, this is nothing but my g. So now the entire problem becomes 0 to ln2. So 0 to ln2, we have here e power t into g of t will simply become this. So that is 1 plus 3 times. So 1 plus 3 times e to the power 2t over 1 plus e to the power 2t. So e to the power 2t dt. But for the safe side, we will take e to the power t is equal to some w. So e to the power t dt will be equal to dw. So in this case, my limit will change. So when t is 0, then w will go to 1. When t is going to ln2, my w will go to 2. So 1 to 2, this e power t dt became dw, and then this is 1 plus 3 simply w square over 1 plus w square dw. Now let's solve them. So this I'll think of separating definitely. So 1 to 2 here, 1 over 1 plus w square like this, and then plus 3 times 1 to 2, w square would be here, and then 1 plus w square. Now this way I can think of adding and subtracting 1, so this will be 1 plus and then minus 1. So once this task is done, this can be further written as integral 1 to 2, 1 over 1 plus w square dw, and then plus 3 times simply integration of constant dw, and then minus 3 times integral 1 to 2 dw over 1 plus w square. Now these two will collaborate. So I get here 3 into 2 minus 1, which is 3, minus 2 times integral 1 to 2, 1 over 1 plus w square dw. So which is nothing but 3 minus 2 times tan inverse of w. And limit goes from 1 to 2. So now we can plug in here upper limit. So upper limit will be tan inverse of 2 minus tan inverse of 1, which is pi by 4. Now this will turn out to be 3 minus 2 times tan inverse of 2 plus pi by 2. And that's the final answer. So 3 minus 2 times tan inverse of 2 plus pi by 2 is nothing but the answer of this thing. Now let's go to the next. So we have question number 35. Let f of x be a real valued function defined on this such that we have e to the power sine x into f of x is equal to 3 plus integral 0 to x square root of 3t square plus t to the power 4 plus 1 into dt. And we are given that g is the inverse of f. So if g is the inverse of f, that means we can extract a very beautiful information from here. G is inverse of f, which implies g is equal to f inverse. That means I get to see here that g of f of x would be equal to simply x. So now I'll differentiate this. So g dash of f of x into f dash of x is equal to 1. Now I need g dash of 3. So for g dash of 3, we need to get f of x must be equal to 3. So what value of x? For what value of x we get f of x is equal to 3. And if you look at this equation clearly, say star equation, I want my f of x to be 3. So for this thing, we can plug in x is equal to 0. So because this integration will be lost, and then e to the power 0 is 1. So set x is equal to 0 in the star equation. So which means I'll be having here f of 0 is equal to, this is simply 3. So f of 0 is 3. I'll call this equation, say, double star. So in the double star equation, we will put x is equal to 0. So I'll be having here g dash of f of 0 into f dash of 0 is equal to 1. So f dash of 0 is f of 0 is given to be 3. So g dash of 3 will be equal to 1 upon f dash of 0. So now the entire problem is shifted to differentiating this function because we need to find out f dash of 0. So let's differentiate this guy. Explain and then differentiate. Come on. Yeah. Man. Okay. Now let's differentiate this thing. So of course, u remains as it is. Derivative of v will be f dash of x plus f of x will be as it is. E to the power sin x will be e to the power sin x into cos x is equal to this will be gone, and we get here square root of 3x square plus x to the power 4 plus 1. Now I want f dash of 0. So set x is equal to 0 here in this equation because we need to find out f dash of 0. So if I plug in f dash of 0, this will be 1 here, and then f dash of 0 plus this is f of 0 into cos 0 is 1, e power sin 0 is also 1. So we get here f of 0 is equal to, this will be simply 1. So f dash of 0 will be equal to 1 minus, and f of 0 is 3. F of 0 is 3. So this gives me minus 2. So therefore, g dash of 3 will be equal to 1 upon minus 2. And now we need here 1 over lambda. So that means lambda is equal to minus 2 here. So this implies mod of lambda will be 2. So that's all. We'll continue again in the next session. Happy learning. Bye bye.